Okay, so first lesson of Unit 7, the expression 12t plus 2.5 represents the cost to purchase tickets for a play, where t is the number of tickets. Be prepared to explain the response to each question. So table 1, a family paid $62.50 per tickets. How many tickets were bought? 5 tickets. And how did you get to that answer? Well, the correct answer is all right, so class, does that sound good? Does that sound like that's the right answer? Did anyone do it in a different way? Amy? And how'd you know to plug in 513? Okay, so that what you're describing, we call guess and check. I saw a hand up. Okay. That what you're describing is called guess and check, which is a method we'll be talking about today when it comes to solving quadratics. This problem is not a quadratic though. So when it has an expression that looks like this, how would we classify that function? What type of function is it if it looks like that? Right, it's one of the 3 we learned this year. It is linear. Okay, and anything that has a variable that is not higher than the first power, so like t to the first power, is going to be linear. And then we learned in the last unit that if it has something to the second power and nothing higher than that, then it's quadratic. All right, but this warm up is still in this unit and stuff because the guess and check method we're gonna apply later today. All right, but really you guys know how to solve this without guessing and checking. Although it is a valid method and it does give us the right answer is 5. But even like Jordan explained the steps correctly, but for someone who might like struggle with math, that's why we teach you processes, like knowing where to plug in this 62.5. Right, I'm not plugging it in for the t, because t is number of tickets, that's what we're solving for. But we're plugging it in here and basically making it an equation that we can solve. And we know that there's a process when we solve equations. When there's only one variable, we can figure out what that one variable is by getting rid of what's farther from it. So yeah, we do need to subtract the 2.5 first from each side. And then we do divide 12 because that's what the opposite of multiplying 12 is. So if you didn't like automatically know the steps of what to do, that makes sense. That's why we teach you how to solve equations. That it's like the same process each time so that you can solve more difficult problems. All right, so we've taught you how to solve before, we taught you how to make an equation. And for number 2, table 2, a teacher paid $278.50 for tickets for her students. How many tickets were bought? 23. And how did we get that number? Okay, good. So this is our traditional way of setting things up and solving. So knowing that if this expression tells us the cost to purchase and their cost to purchase was this much, then, make it equal to that and solve for t, which is what I'm doing right now. And then it does end up equaling 23. In an earlier class today, someone guessed and checked this one. And they started with like their first guess being like 9 for the T. Like they knew it had to be something greater than 5 because the cost for 5 tickets was this much. And since the teacher paid almost $300, they knew it was going to be more than 5. And then once they saw what that was in their calculator, they adjusted their guess based on that until they found the right answer. All right, so it works pretty nice for that. I mean, I personally think that this is more logical and will get you the right answer faster. But in guessing and checking, it might take a while, but it is possible. And in this one, you can't really buy like a fraction of the ticket. So when it's full numbers that you're plugging in, it's not a bad method at all. All right, so that is a unit 2 skills. Hopefully we were all able to get that no matter what method we did. Today we're doing a combo lesson because really it's a lot of review and kind of just getting you to notice something. So make sure when we get to the other activities that we're actually trying so that we can notice like which one thing that happens and understand the later lessons better. But unit 7 is also about quadratics as well. It's just more about solving them. So solving is finding the value of the variable that makes it true. By the end of the lesson, you need to be able to explain the meaning of a solution in terms of a situation. Write a quadratic equation that represents a situation. Recognize the factored form and know when it can be useful for solving problems. And how to use a graph to find the solutions of a quadratic equation, but also know its limitations. So in the last unit, we did a lot of graphing to find the answer. We're not necessarily going to do graphing that much today. You have to learn all of the different ways to solve the quadratic equation. We're not necessarily going to learn them all today. But the questions on the test are not necessarily going to be things that you can just look up by graphing. That's why it's important you know how to solve them algorithmically. So I'm recording right now. I update the lesson every year, but you can watch the one from last year. The math of it is always the same. The practice is actually 2 separate assignments, so make sure, like, they're both not very long. I shortened both of them, but they're just written separately, so make sure you give them both a try. Start off this unit strong. And I do still need to give you back your packets from your corrections that you did yesterday. It's just, I grade 1 page at a time, so I'm almost done, but we'll see if I finish it during this hour. Otherwise, I'll just have to give it tomorrow. You will get it back, and really, you get the full points if you correct every single one you got wrong. Like if you left it blank, yeah, it's wrong because it would be a 0 or that one you left blank on the test. But you correct every single one that you got wrong with work shown, a sentence or 2 if it's not one that you can show work on, and you can resubmit for more points. What I have up on the screen is an extra credit assignment. It's right at the top of Schoology. You really can't miss it. That same title. And it's to kind of make up for any lost points that happened over these past couple of days related to ACT Aspire. So that extra credit assignment is basically like a retake. It's really similar to the exemplar test, just different numbers. But just in case you want to get more practice for your ACT Aspire, but it's not necessarily required. continue working on increasing your IXL skills related to ACT Aspire after ACT Aspire math, the one we take on April 8th. We're not necessarily going to be tracking this anymore. We're going to have you just focus on whatever unit we're doing. So all of those like skills that it recommends from your diagnostic test, you'll see that they're usually pretty easy and you can knock out a lot of extra credit with that. Do that, submit them by April 7th, because April 8th when you take your race. Yeah, talk about that for. So there is one quiz for, well, there's actually two quizzes for Unit 7, but there's going to be one that you take before this date. But we all know quizzes are not nearly as important as our state testing. So state testing is our next like big thing that's coming up. And then here's like the major assessments for the rest of the year, including finals. All right, so lots of information I just said. If you have any questions, do let me know. We're gonna go back to the activity. You're gonna go to the next one that says what goes up must come down. That one is review. You guys should be able to answer that whole section using that graph because we just tested for it in Unit 6. So a mechanical device is used to launch a potato vertically into the air. The potato is launched from a platform 20 feet above the ground with an initial vertical velocity of 9. This function, h of t, models the height of the potato over the ground in feet t seconds after launch. Here's the graph representing the function. For each of these questions, which again are all review questions, I would expect correct answers from each of you. You need to answer it and then show on the graph where you found the answer. We'll go over that in, I'd say, 3 minutes. Okay, table 3. What is the height of the potato 1 second after launch? And where did you look on the graph to get that answer? Okay, so be a little more specific. So 1 on the x-axis, because that would be 1 second, right? The x-axis is labeled as seconds. Look up to where it touches the line. Do you guys agree that that's about 96? And did you like also graph it in desmos? Because 96 is like a really specific number. Okay, also graphed it in desmos and looked where it touches exactly. Because from here, all I can really tell is that it's just right underneath the 100. So close to 100, but not exactly 100 would be another correct answer based on what we're given. But 96 feet, and here is where we look for our answer for number 1. So we also had to mark it on the graph. All right, questions on that one? All right, so then table 4. 8 seconds after launch, will the potato still be in the air? And where did you look on the graph for that answer? At the 8 on the x-axis. And it doesn't touch the line that's graphed. So, yeah, that's a yes or no question. So make sure we're answering it clearly. And that's where we found our answer to number 2. We look on the x-axis, because that's for seconds, and we see that there's no line there. Line ended over here, so that means it took less than 8 seconds for it to reach the ground. Table 5, will the potato reach 120 feet? If so, when will it happen? 1.5 seconds. So that means it does reach 120 feet. Where did you find that on the graph? Where did you look? Right. The 120 on the y-axis, because the y-axis is for height. See if it touches 120, it actually touches the 120 in 2 spots. So there's 2 points that it had that height. But yeah, it's probably asking for when it first reached it. However, it did also reach it a little bit after 4 seconds. And I'm gonna put approximately, I don't know if it is that exactly, but that's where we found the answer for number 3 is these blue dots. And unless you are having access to a graphing calculator, you usually have to put approximately, because unless it's right in the middle, that tick mark, you can't really tell. And table 6, when will the potato hit the ground? At 6 seconds. It looks like it is touching it exactly there. It might be a little bit before it, but 6 seconds. And in this case, like the other ones had numbers specific to where you need to look. And you can see the numbers labeled. This one just said, when will it hit the ground? So you know that the ground would have to be like my x-axis essentially, because my height at the x-axis is going to be 0. Right? And also just common sense. Like if it goes up and it goes down, it's not going to have a negative height at all. So there where the height is 0 is where I need to look, and it touches it at the number 6. And this is where we found the answer. So that ground would be when the y equals 0 or basically your x. Now remember that when we talk about the next activity, so we're actually going to skip this problem, or no, we're not skipping this. We're using that to answer it. So here's the function modeling the height of a potato in feet t seconds after being fired from a different device. So this looks similar to the one we had in the last problem, but it is different. It's now f of t. You see some things being the same still, because gravity still affects it the same way and stuff, but different situation now. The question is, what equation would we solve to find the time at which the potato hits the ground? So think about that. We're going to talk, I'm not necessarily going to give you time to solve it and then come back. We're just talking about it right now. So we're not necessarily graphing this. In fact, in number 2, it doesn't want us to graph. If I were to write an equation, so here's the given equation, I have function notation, remember how that works. What would I need to write in order to solve for when it hits the ground? Asking all of you, so raise your hand when you think you know. For function notation, there's only 2 places I can plug anything in. I could plug it in for the input or the output. So think about what we just talked about in the last activity. If I want to know when the potato hits the ground, what do I need to plug in and where? Zero for the t. Okay, so let's evaluate that for a second. T stands for what in this situation? 5. Time in seconds. It says T seconds. And the question is, we want to find the time at which the potato hits the ground. So if I'm plugging in 0 for the T, that's actually finding something else. It's not finding when it hits the ground. If I plug in something for the time, then that implies I already know the time when we're actually solving for the time. So what we're solving for is the time, so we're actually not going to plug in 0 for the T. Whatever we're solving for should be what's unknown, should be represented with the variable. So then the only other place to plug in would be where? I don't know how to make it simpler. I just said we can't plug it in for the T, so where's the only other place I could plug something? I'm not just going to come right out and tell you, so someone needs to know. It's in functional notation a lot. I mean, we already canceled out T. If it can't plug into T, where else can we plug in? F of T. So, and what will we plug in for the F of T if I want to know when it hits the ground? 0, good. If I want an equation that will tell me when the potato hits the ground, so we're solving for the seconds, we're solving for T, I'd have to plug in a 0 for the F of T, which F of T gives us the height of the potato, which makes sense. If the height is 0, that would be when it hits the ground. Make sense? Maybe? Hope so. You're gonna have to apply that multiple times. Think back to function notation. F of x equals y. X you usually know as your input. Whatever's in the parentheses is your input. The y you know as your output. But the output is given, like it's equal to this notation as a unit. All right, so the x alone is the input. F of x together gives you your output. Okay, so if I want to find when the y is 0, we just talked about that in this one. When the y is 0, that's where the height is 0. That's where it hits the ground. I have to plug that in for the y in the given rate. Okay, so this is the equation that answers that question. And it says use any method except graphing. So don't graph it. But you can use your calculator. I mean, I don't know how else you would solve it. Find the solution for if this is my situation, when will the potato hit the ground? I'll give you, I'd say, a minute or two. You actively try it. In my first hour, I feel like this part took a really long time because people weren't trying. Find a way to figure it out without graphing. Anyone think that they have the answer for what time that would reach the ground for that given equation? If you graphed it, definitely don't tell me because it's supposed to do it without graphing. and compare it to what we did in the warm-up. In the warm-up, there was all these different ways of getting the answer. Remember, and solutions are values for the variable that make it true. So like in number 1 for the warm-up, 5 was the value that made it cost $62.50 after fees. 23 was the value that made it cost $278.5. So what value can I plug in for the t to make it equal 0? All right, anyone think they have it? Think they have it close? Longer this takes, like you just might not have time for homework. I got other things to do. How long did it take the last example to hit the ground? Okay. Do we think it might be near that? Do we think it's closer to like 30 seconds? How long does it usually take for something to hit the ground in these problems that we do? If you tried isolating the variable for this, because that was one of the methods we tried in the warm-up, it wouldn't necessarily work because there's two variables. And normally when we isolate variables, there can only be one. Because then from there we pick what's farthest, get rid of it, and go from there. But we can't do that right now. The only other viable method, because I've not taught you the other methods of solving, that comes later in the unit. The only other viable method is to do the guess and check. So pick reasonable guesses, like should I have negative time in this situation? So don't plug in any negative numbers. Don't plug in any extremely large numbers because it shouldn't take that long for something to hit the ground. And I'm certainly not going to come out and tell you the answer. So figure it out. You guys all have access to calculators. You guys all know how to guess and check. Let me know when you think you have the answer. All right, so remember, solutions, when it says solve something, we want the value for the variable that makes it true. We set up the equation together. If we want to know when the potato hits the ground, so when the height is 0, the only viable method we could do without graphing is guess and check. So what you should have done, those of you that didn't try at all, is plug in different numbers for the t, and you could start with like the one from the last problem. See if it takes also 6 seconds for it to hit the ground. All right, so this is me plugging into my given equation 6 as a possible answer. 6 I know is not the answer because it's not giving me a 0 here. It's giving me, like if we were imagining the graph, it's giving me below the x-axis a little bit for the height, and I shouldn't have a negative height. So that should tell you that at 6 seconds, it's already hit the ground before that. So then adjust your guess. 5 seconds is now a bit above the ground. So now it's telling you it's somewhere between 5 and 6, and then you adjust your guess based on that. So like 5.5, it's getting closer to the x-axis, but not quite. 5.7 is the closest we'll get for decimals right now, for guessing and checking. Because if I try, say, like 5.8, we're now underneath the x-axis again. So the closest decimal that we could guess and check is 5.7. So T being approximately 5.7 using the guess and check method. So if it's multiple choice and like you won't have a graphing calculator unless you bring one on your ACT Aspire test day, if it's multiple choice, you could try plugging in the answer, see which one gives you this and makes it true. All right, when I do have graphing technology available, which is what you did in your last test, let's see what that answer ends up being. Notice we have two x-intercepts, only one of them makes sense. And this is the decimal for when it actually hits the ground. 5.7 is a good approximation. All right, so questions on that. So we're going to skip the one about revenue from ticket sales. We're going to go right into this. What are some limitations of solving a quadratic by guessing and checking? It has this as an example, but you just saw it in the last example we just did. Why is guessing and checking not necessarily the best option all the time? It might not give the exact answer. If your answer is a decimal, it's hard to guess exactly what decimal. It's not impossible, but it is harder than say like in the warm-up where you can't buy a decimal of a ticket. And I'm sure there's others, but that's usually it. It usually takes a while to guess the correct answer right off the bat, but it is possible to. Now for graphing, let's see what this one looks like graph. Negative 2x squared minus 2x plus 40. And here, when it's just up to that point, it gives me a nice U shape. But they're not putting it equal to 0, they're putting it equal to 10. So look at that graph. What are some limitations about this graph? Can I see the U shape? Right? No. Can I see the x-intercepts? Can I see the solutions? Yeah, that's just about all you can see though. So graphing something like this, I don't know about for limitations, but the graph can be confusing. And it's not showing you all the detail. It's not showing you the vertex. It's not showing you other parts, like if you think of the last example with the graph that you can see all along that U shape. You can't see the U shape when you see the x-intercepts. Now, these next two questions are more like opinions. But one of the learning targets was seeing if we can recognize the factor form and when it might be better for solving. So in number 2, look at these two expressions. Or equations rather, they have equal signs, so they're equations. Which of these equations would be considered the factor form? First one or the second? What do we do with factors usually? So which one can be multiplied out. So reminding you, we learned all the different forms in the last unit. Factored form is when you can multiply it out, if it's written as factors, versus standard form, where you can see the x squared and there's nothing else that needs to be multiplied. Now, both of these are set equal to 0. It's up to you, like it's kind of an opinion question, which one you think is easier to solve. But I'm gonna say this one is easier to solve, because you should know that if I have two things being multiplied together, so I have this parentheses and this parentheses being multiplied together. If I multiply and I get 0, what must be true about one of the things I multiplied? Do all the look up here. I'll say it again. So tune in. If I'm multiplying two things together and it equals 0, what must one of those things be? It must be 0. So that's why I'm saying the factor form, it would be easier to figure out what x has to be, because it's equal to 0. And I know that. All I have to do is figure out what does x have to be to make this parenthesis 0, and what does x have to be to make that parenthesis 0. This one, I know it's pretty easy. If x was -5, -5 plus 5 is 0, right? This one over here, not as easy to see, or maybe it's easy to see for you. But if I had to figure out what x has to be to make it 0, I could just set it equal to 0 and solve. And that would be subtracting 8 on each side. Dividing by -2 on each side. And I get that x can also be 4, and that also makes it 0. Because it doesn't matter which one is the 0, and that's why there's usually two answers. It could be the first parentheses that becomes 0, or it could be the second one. So when it's set equal to 0, I would say the factor form is easier to solve. For this one down here, what's the only difference between these equations and the one above it? The thing that it's equal to. I don't want to say answer because technically solutions are values for the variable, right? What it's set equal to is different. Over here it's 0, over here it's 10. Would the factored form still be easier to solve if it's equal to 10 instead of 0? How many different ways can I multiply to get 10? Give me two numbers that multiply to give me 10. Are there others? Some others. Good. And then if you think about decimals, like you could even do 2.5 times 4. Like there's lots of ways to get 10 by multiplying. And for example, if I were trying to solve what has to make this one 2 and this one 5 and vice versa, like that is way harder to figure out, because that has lots of different ways to get 10. I know that if I'm multiplying and I'm getting 0, one of the numbers has to be 0. And that's why it's easier, if it's set equal to 0, to use a factor. So it's not impossible, but for this one, I would say that the standard form is easier. But unless you're graphing, it would have to just be by guess and check. All right. So if you think back to our learning targets, we did meet all of them. It's mostly just about seeing certain patterns right now and a little bit of review. Do you have any questions? Well, you have 2 practices. Most of you have your computers up anyway, so I wouldn't send them away yet. You have plenty of time. At 10:29, you can pack up. Let's see if I can. I don't think I'll have time to pass back the packets today. I'm so middle. But definitely for sure by tomorrow, I should have this for you.